Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is Zweig from Ribbon Communications, expert in all things voice over IP, and well, they also do session border controllers. And I think you also have an offering in optical networks. So I'm curious about what that actually is. I'm an application guy myself, so I live uh, the level above of what you described. So that's always going to be useful. So first of all, thank you for joining us.
Well, Luca, thanks for having me. Look forward to the conversation today.
Of course. Would you like to give us a quick introduction about yourself, how you started? It's always interesting to start from there.
Sure. Well, my background is kind of interesting. I started my career a few years ago, I guess I would gently say nowadays.
Hmm.
I actually started with AT&T back in the 1990s,
Oh, wow.
and then kind of had an interesting activity in the late 90s. I was working for AT&T, and I kind of fell into a small company here in Boston where I live today who was working on something called the Voice over Ethernet PBX.
Oh,
L-
nice.
Little company called NBX Corporation, and I joined that as an employee 12. And we really were the first company to ship a dedicated voice over IP business phone, and we built an IP PBX, and that sort of started my uh, career in voice over IP. And so I've really been involved in it really since the very beginning. I mean, our first phone used a TI 203 DSP in it, and the PBX was a 48666 processor. And
Oh,
by the time I left that organization, the DSP in the phone had more processing power than the original entire system had. So amazing how much in just a decade or so the field changed. And so I've done that, and I worked for many years as a product manager, and I moved into the marketing space as years went by, and sort of the world changed. And so I have worked for Ribbon now for roughly a decade.
nice. Yeah, the moving and the addition of power to networks has been, well, accelerating like everything else. Now we have 5G base stations who can run as much processing power as a server had, 2, 3 years ago. It's just a new thing. So what does Ribbon do? It's
Well, that's a good question. So Ribbon really, I'll give you a little history. Some people don't always know the brand. It's only about a 4-year-old brand. It was formed in 2017
Mhm.
with the merger of Sonus Networks, which many people know from the session border control
Yeah.
space, and Genband, who has a long history in telecom carrier space with gateways. And actually, kind of interestingly enough, Genband in 2010 acquired the Nortel carrier assets. So Ribbon now owns all of the legacy Nortel environments, and over the years has been migrating those into modern environments for more than a decade. And then probably more recently, the things we're known for is Ribbon acquired Edgewater Networks, which some people might know, kind of smart edge devices. They're all
Mhm.
over the world. And then in 2020, we acquired ECI Telecom based in Israel, and that is where we really transformed the company. And so now we're both a traditional, I would call, telecom infrastructure company, as well as an IP optical company. So we almost doubled the size of the company. Ribbon today is maybe about between 3,500 and 4,000 employees, and we do businesses in 140 countries across the globe.
Oh, that's so before we delve into the, let's say, more telephony oriented aspects, which is the session border controller, what you can do, how do you want, why do you want one? I'm curious about the optical part because I don't really know what that is. So what does that mean?
Well, really, in many regards, I guess, you think of it, I'd put it in my sort of simple mind of my history is, really there's two pieces. We have what I would call traditional, network switching and routing type assets. Uh, but we really focus on things like critical infrastructure, so
Hmm.
high performance, high availability type solutions. We're not focused on making a 10 port desktop switch, right? So we have a we have a focus there, and then on the IP optical side, it's really about high performance fiber
Oh,
networks.
I see.
Right?
So effectively, it's connecting equipment using optical fiber instead of Ethernet or copper.
Absolutely, and a lot of focus on things like metro area networking, 5G backhaul. A lot of again, we work with a lot of telecom providers and other large industries where maybe they own their own backbone, or even large industries where people want to take a dark fiber and build their own networks. As much as we think about how readily available bandwidth is, many of your viewers know that when you leave large metropolitan areas, you don't necessarily always get the same coverage. So
Oh yeah, I know firsthand.
yeah, so if you leave a large, if you have you're a large conglomerate, and maybe you put you're an auto manufacturer. I can think of somebody who we deal with, a big well-known auto manufacturer. They have design and plant infrastructure in places that may not have the kind of traditional commercial infrastructure they need to run their network. So they put in their own fiber and built their own fiber backbone to support themselves. So that's a great example where our equipment might be used.
Yeah. Well, yeah, I was just curious because as I was saying, I am a developer. I do architecture. I do a lot of that. So we generally exist outside of that realm. While SBCs are very much interesting for to me because it's where you can do a lot of work. A lot of work happens. People underestimate how much you can do with that. It's not a firewall. So what is an SBC? We never actually ask questions like that in the show, so it's going to be useful.
Well, it is sort of a firewall in the sense that it serves much of the same function, but it's
Hmm?
focused on real-time communications, and it's a back-to-back user agent. So the way I think of it in a lot of regards is, I use the analogy. It's really like a border crossing between two countries, but
Hmm.
because it's a back-to-back user agent, if you think of, the analogy of a packet being a truck, right? You instead of just allowing the truck to cross the border the way a firewall might,
Hmm.
the SBC will actually open the truck, inspect the contents, pull all the contents out,
Hmm.
and then put it back in the truck, reassemble it, and bring it to the other side of the border crossing. And it does all of that at wire speed. And that's really powerful when you think about it from a security perspective, because there's no chance that what's inside of a packet isn't going to be understood. And
All
then
right.
from a VoIP perspective, what's really compelling about that is we can kind of reshape that packet when we reassemble it, put it
Oh
back in
yeah.
the truck. We can change the headers if we need to, because I'll use a railway example. In Europe, you want to go from the Russian railway to the Western European railway. The railway size is different.
Oh
So,
yeah, for sure.
that you run into that a lot in SIP, right? There's a lot of scenarios where people use a slightly different header. They've made a slight modification, and then suddenly what should work fine doesn't work properly. So we have SIP header manipulation. We can go in and change that. We do things like we can support a huge variety of codecs, things like EVS, the Silk, any of the
Oh
newer
nice. Yeah.
high bandwidth codecs. But conversely, if that's what your network is set up for, and you need to go back to plain old G711, we can get it back there.
Yeah,
So
you
that's
can also you could change labels on a packet too, like say make it go a different place. So yeah, that's a very good analogy, I think.
yeah, yeah, absolutely, yeah, that's right. You could change the map inside the truck.
Oh yeah, for sure. So what's the what's your typical customer, which leads into the discussion of what how does a company use an SPC and why does it help them?
Well, really, we have two groups of customers. And I'll just kind of touch on the first and then go into the second, which is we have a lot of large telcos as our customers. So most of the big brands that you can think of out there globally, we have a huge base of large telecommunications companies, and a big group of of cloud communication providers as well who use our SBCs, and they're really the first point of security to their networks for, it can really be hundreds and hundreds of thousands of sessions,
Oh yeah,
concurrently
for
going
sure.
on, right? And then we also have a whole set of enterprises who use our solutions. And really, I break those apart into two groups. We have small, medium business type environments, and those might be scenarios where somebody has you think of a classic kind of pizza box environment,
Mhm.
might have 20 ports, 20 concurrent sessions on that. And they're just using that much as we described for just robust security, little interoperability. We also have gateway services. So sometimes somebody will have they have an old piece of equipment that still has PRI on it and or BRI or
Oh
analog.
yeah, for sure.
They need a little bit of they need a little bit of gateway, so they mix and match. They use us as the kind of intelligent endpoint for their SIP trunk, and then they secure that trunk as well as
There's more of those that are still alive than we can think of. There's a lot.
well, to give you an idea, I shipped the first voice over IP phone in October. It was Halloween of 1998.
Wow.
So, but yet here we are. I can walk into any hotel in the United States and look down at the phone, and I bet you that 85% of them are still a TDM phone running the
Wow.
front desk, right? So you're absolutely right. Um,
Yeah, it's been a while. I mean, we were discussing this in an episode recently. I think some of those infrastructures are not really going to go anywhere soon, if ever. Like most of that stuff is going to stay until it keeps working. Uh,
yes,
it's not like the expenses can be huge. Like there's some organizations have what 10,000 phones easily, and I
yes.
mean,
We we support a bunch of large universities, and I can think of like the University of Texas, who's a customer of ours. And they one of the reasons they're our customer is because they basically use almost a carrier class switch. They have
oh yeah,
40,000. They have 40,000 endpoints. That's bigger than the town I live in, right?
yeah. So
So
change all of those phones is easily an 8 million operation, easily,
exactly, and it's
probably more.
yeah, and it's hard for them now. They've upgraded. Their core of that network is now IP, but they still use a lot of the legacy infrastructure around that campus. They're not about to start digging up their entire campus just to change phones.
Yeah, the very often the change you want to do is really just upgrade in a way that's not too expensive and seamless, which is the main issue.
Well, and they again, like many of our customers, they have to be very concerned about their security. They're a target, obviously.
Mm.
Most universities are a target at a couple of levels, right? They're a target for now. Unfortunately, they might be a target for state-sponsored terrorism, which seems hard to imagine, but that's the world we live in. But they're also a target for many other kinds of they could be corporate espionage, someone trying to steal research. It just goes on. So they have to be very attentive to their security as an example.
Random, which it leads into another interesting consideration. I am as I said, I'm an application developer. I do know my way very, of course, very well around telephony, especially for switch SIP setting up with an SPC, open source stuff mainly. But everybody knows that if you put the SIP server on a public IP, it takes anywhere from 5 to 12 minutes to get your first attack. And once the server responds in any meaningful way that can be interpreted as there is some kind of SIP server active on that IP address, that ramps up in a way that often makes things almost unusable very quickly. At least, at very minimum, you can't read logs. So, how do your products mitigate that kind of attack, which is the main thing? As you know, most of these are tried by brute force because SIP lends itself very well. Unfortunately, it's brute forcing. It's stateless. You can just send register packets forever and see if you hit something.
It's a great question, and I talked about the fact that we have these small medium businesses, but we also have a lot of large businesses as well. And I'll give you an example. We have one of the big major airlines here in the U.S. and actually airlines all over, and they have a big contact center, right? It's all SIP based.
Of course.
And this is exactly what happens to them. And they actually get hit in two directions, Luca. They
What?
get they get the denial of a service attack
Oh yeah.
on the SIP side, but they also get denial of service attacks against their PSTN numbers, right? So
How do you
people,
even do that?
oh
They
well, it's
just
not,
get cold?
you just all you do is you try and figure out what the local telephone numbers are associated with the 800 number, and or even the 800 number, and you just start pounding that number with traffic, right? And your objective is that attacker is to disrupt and slow down, right? So
Call
you
center becomes unusable very quickly because all channels are tied up. No matter how many you have, eventually they run out.
and again, hard to imagine, but you have people out there who think to themselves, well, if I can bring a company's contact center down, I can impact their stock price for the day, right? It's hard to imagine, right? That somebody might short a stock and try and create a business disruption and try and make money from that, right? So you think, why would someone waste their time doing it? It's not always ransomware. There's a million crazy things that people do that drives those decisions. But pursuant to your question, there's a couple things. So uh, one of the things that we do is we focus a lot on survivability of our assets
Hmm.
because we put them in front of these kinds of services, both from a telephony perspective and a data perspective, and we really do overbuild. And the reason we do that is so that we can take those kinds of traffic hits and basically sit there and wire speed sort what's real and what's not. And as we do that, we essentially filter out from the telephone server the trash, right? So we're
Oh,
constantly sorting the wheat and the chaff. And we have some tools, and it depends. In the case of something like on the telephone side, we have third-party databases and other things that we can add in query to look for known bad numbers and try and get those out of the picture early. But there's a whole series of techniques that are in place to basically constantly sit there and try and sort out good traffic from bad. And to your point, right? So you see a known bad actor because you've opened the packet and seen what's in there. Then you start ignoring that bad actor, right? Whereas what would happen otherwise is your server would keep looking at everyone, right? It would keep looking. If the bad actor sends another bad packet, it would keep looking.
hmm. Oh, know what happened here?
I don't know, but it looks like we're being hacked.
Huh. I don't know what that. I have no idea what that was. I'll go check with my friends. Oh yeah, something happened there. Well,
I
was
I
someone?
I think we were hacked.
I think it was a misclick by someone in the lobby. Well, or oh
It's
wow, so it's still going on. I'll go ping the guys and we can cut this, no problem.
back.
Go. So, well, we can probably just give me a sec
Sure.
and we'll start over. No, well, looks like we're safe now. Cool. So, going off from there, what are the most common types of attacks you're seeing? You think denial of service is the most common these days? Because back when I started, I would say 2007, 8, we were seeing more toll fraud than denial of service. Like people were trying to dial out.
Yeah, you still see some toll fraud. That still exists for sure. Over time, I think we see less of that because the nature of how telephone billing works, it's less impactful, right? People have unlimited dial plans, and so the value of that toll fraud has declined. When I first started my career, you'd have crazy scenarios where people would literally set up a payphone in the middle of a neighborhood somewhere and
Mhm.
start ad hoc charging people cash to make calls to other parts of the world. I mean, it seems almost ridiculous now, right, to think of that. But but that was very viable because the value of that long distance call was so great.
Oh yeah, for sure.
Today with between WhatsApp and a variety of other tools, it's just not the driver. But I'm not saying it never happens, but it's not the primary driver. I think the driver today is much more around how do I disrupt that business. And so denial of service attacks are very impactful. The other thing we worry about more and more, and I know this has been a concern recently in the open source community, is we worry about somebody using the IP network that the telephone services are connected to. Basically, use the telephone services as a point of access into that network,
Hmm.
right? And so I kind of use the analogy of sometimes, people build this enormous, they put 15 locks on their front door, and yet they have telephony services coming into their network in the side door, and that's wide open. So at the end of the day, today, modern telephony solutions are all running on that same network. So you really have to secure everything that's part of the solution. And so a lot of what we
I
do
see.
is make sure that the rest of the network is secure.
Yeah, which is it's always a concern. I speak from experience. I always admit to this of being guilty of something that happened a few few years ago. I set up a asterisk server, actually it was asterisk, and I loaded up the production profiles for the gateways, but the developer profile for the dial plan. So you will be able to dial anything you wanted, and as a result, we got a call from our provider who had temporarily suspended the account because we had incurred $4,000 of traffic in just a couple hours. Because someone by trying to dial outside, they managed to dial what they were doing at the time. I assume they still do it. So this may be a question for you if you know. They were actually dialing out to a foreign, those additional toll numbers.
Oh
There was
yeah,
like $20 per hour. So effectively, what happens is that it drains your credit super fast because $20 per minute, not per hour. And
yeah,
they went to as many channels as we had. They were just dialing to this number from Eastern Europe, and it drained like 4K in in a month in 2 hours.
yeah. That's a great example of sort of a more modern form of toll fraud, because what they've done is, for if your viewers don't fully grasp, is that they've used a number that has some sort of a bill function associated with it. And what they're really doing is making your asterisk box into a traffic generator
Hmm.
and using your account as the bank for that. So they're essentially hired by that. Oftentimes they're hired by that the person who owns those numbers, those premium numbers, I'll call them. They're hired to generate traffic to those numbers.
Yeah, I figured that it's not. I mean, it's still a lot of damage you can do to a company to just spending their money. But of course, it's much worse. It's much better. Not well. It's much better
Yeah.
hacker's perspective. It's much better if you get that money as opposed to just having you throw it away. So I can see that.
Well,
I
and
can see.
and and I think the thing about toll fraud today is, particularly in larger companies, I'm not going to suggest that people don't worry about it, because they do. But the ransomware and the denial of
Oh
service
yeah.
attack and other things, those can substantially injure a company, both privately and publicly, in the sense that, from a private perspective, it can really be a huge financial burden, but publicly, it can shake confidence in an organization. So I think today, IT organizations are exponentially more concerned about that, because they're worried that, no, as I always say, nobody wants to end up on the cover of the Wall Street Journal or the Financial Times, right?
Yeah, that's probably it. Yep. Well, another thing that's been happening, and you know that all governments have been putting out all sort of rules against robocalling, spam calling, and all of that stuff. But it works. But you have to put yourself on a registry, and you usually do get a few calls still. What do you think is the role of an SBC in there? Do you support stir shaken? Do you use some other pattern? That's actually a very interesting angle.
Yeah, well, it's certainly a big challenge, and it's challenging in a lot of ways, because in some cases there's also what I'll kind of call rogue actors from in the service provider community too, where people have essentially, you know, there's individuals who've gotten a license, let's say, to be a service provider, but they're more focused on how they can enable, or their business model it was partly to turn a blind eye to what was a lot of traffic that was being pumped into their networks by these robocalling solutions. Um, and and certainly the regulatory bodies worldwide, I think, have
Mm.
finally gotten the message that they need to take an aggressive role here, and I think that's best for everybody involved, because I think ultimately it hurts everybody, including the consumer, when you can't count on who's on the other end of the call. I mean, we've taken for granted for since the beginning of the telephone network that there was a legitimate individual on the other end of the call, and that's not the case. But our SBCs absolutely support Stir Shaken, and we have something we call voice threat prevention tools, where basically we have databases that are a combination of our own databases and then third party, where we attempt to look for known bad numbers. We try to pull those out, and so prevent those calls from coming to the end users in the mix. There's tools in the network now to certify calls. That's part of what Stir
Mm.
Shaken does. So we try and deliver that across the infrastructure. There are some challenges still. The IP network, the core
Mm.
backbone of the network that's still IP, has a lot of ability to tag things and add information. But the legacy TDM network, which there's still a lot of, doesn't have those same tool sets. So there is a challenge, because in some cases a call could get tagged in the IP network, and if it goes across a TDM network, is
Oh.
transported across that TDM network, that that information may get lost. And so there's still work to be done to fully secure the telecom network everywhere. But it's getting better. Service providers have spent billions of dollars, I think, trying to improve this, and the regulatory bodies, I think, have been pretty aggressive. There was just a huge fine levied, I think, in the U.S. here recently by against a few rogue players. So I think governments in general have gotten more serious about it.
Yeah, it is. The TDM part is very true. I work with the working group on Store Shaken and collaborated with the implementation that is lib Store Shaken, which is the open source implementation we released, and it's a very good tool that I advise everybody start using for if you want to incorporate Store Shaken into your own stuff. It's open source, of course, but the TDM part, the Shaken part. So TDM will be the Shaken part for people who don't know. Stir is for SIP, and it has certificates and it has certificate checks, and it's similar to HTTPS. Effectively, you're trying to figure out this number is saying they are from Greg.
Right.
They're presenting this certificate saying the number is from Greg. Let me check if whoever issued the certificate says the certificate was issued to Greg Zweig or to someone else. So
Right.
that will be the stir part. The shaken part is harder because it's still up in the sky. I think I feel like it's been a bit hand wavy by whoever defined the standard, because it's supposed to work that your device, your TDM device, should be able to ping something to do the same check that we just discussed in stir, but it's really not easy to do. Plus, most of those phones won't change, right? So it's
Yes.
very hard.
The thing that the TDM network has going for it in this equation is, because it's more, I'll say, kind of hardwired. It is harder to provide rogue information in the middle. You do need all those fixed connections, and so since they are fixed connections between two providers, let's say,
Mm.
it's harder to sort of be that nebulous man in the middle who inserts themselves. Each one of the, every service provider who peers with another provider, they know exactly who that is and how that connection is routed, because it's a physical entity. Whereas in the IP world, they're certainly, they know who the other peering partner is, but the steps that it got into their network may be a little less clear. And
Hmm.
so IP makes it easier for a hacker, for instance, to present a different caller ID or present a different name as they drive something into the network. Because it was designed, of course, that was designed to be a benefit, right? That we could do things like rather than present your DID number, you could present the main number of your company, and rather than present your name, you could present your company name because maybe you're somebody who doesn't want to be called back directly, right? Those, which is a very, I'm a call center agent at United Airlines or at Lufthansa. I don't want somebody dialing my direct number back. I want to present the 800 number of my contact center. That's what those tools were designed for. But as with every good idea, somebody has come up with a way to use it.
Yeah, that's probably true. Yeah. So would you say that in a world where protecting traditional devices is hard because they don't have, I mean, they're literally not designed for that, putting an SPC that's capable of working as a gateway for legacy stuff in your organization will be useful. Feels like it is. Like it will
Yeah,
be
absolutely.
the
It
first
is.
step, probably.
No, nobody would put an IP network in place for data and not put a firewall in. So if you're using real-time communications, you should have a security element as part of that.
Yeah, I totally agree. It's probably the best we're going to get for a while, even if it sounds silly like this. Just because of how things are built, really. It's network works these days. Cool. Well, Greg, thank you so much. It was great. It was very instructive to relearn about SPCs, what they should do, what people should use for it, and I'm sure people will be able to reach out to you. Do you have a well? Can they just contact you through the website? Or like, do you have an email address they can ping you
They
at?
can use either. It's just RBB. It's rbbn.com. So ribbon, the shortened ribbon, rbbn.com, and they can just use my first initial and last name at rbbn.com if they want to reach me directly. And we didn't really touch on it, but we also do a ton of work with Teams and Zoom and the other collaboration tools as well. So whatever obviously, I know most of your customers are focused on the signal wire solutions and open source, but regardless of the application, we have solutions for it.
Well, that sounds great. Yeah. So reach out to Greg or reach out to myself. I'll put you in touch if you need anything. And what we discussed sounds interesting. A quick reminder: ClueCon is coming back in October, and it's going to be in Chicago from the 15th to the 21st. On the 21st, I will be doing the first switch training myself. So come have fun. And it's going to be great to be back in person. So, well, Greg, if you'd like to come say hello, we'll be there, and everybody else too. Cool. So again, Greg, thank you very much for joining us today, and I'll I'll see. Well, for the rest of the audience, I'll see you next week.
Thank you very much, Luca.
Have a good day.